Bismillahirrahmanirrahim. Assalamu alaikum dear students. We are studying Cambridge International AS and A-Level Mathematics. Today is our lesson number 6. In lesson number 5, there were some questions which you were asked to try. The answers of the questions are, this is the sketch of question number 1 and this is the sketch of question number 2. Today we will study quadratic inequalities. Lesson objectives are that after this lesson you will be able to solve quadratic inequalities by graphing method, by number line and sign check method, and by completing the square method. Quadratic inequality in one variable. Let us first define what is quadratic inequality in one variable. Earlier you have studied linear inequality in 1 and 2 variables. A quadratic inequality is a mathematical statement that relates a quadratic expression as either less than or greater than another. After rearrangement, quadratic inequality has the following standard form: ax square plus bx plus c greater than or equal to 0, where a should not be equal to 0, is a quadratic inequality. We can replace this inequality sign by any of these three inequality symbols also. So there may be any one of these four symbols which will form the quadratic inequality. Solution of quadratic inequality. Solving a quadratic inequality means finding all the values of x that make the inequality true. These values of x constitute the solution set of the inequality. The solution set of quadratic inequality are expressed in the form of intervals, all range of values of x. In our syllabus, A-level syllabus, Cambridge, we will write the solution in this form: range of values of x, which will be in the form of inequalities. Methods of solving quadratic inequalities. There are three methods of solving quadratic inequalities. There are many more, but we will study these three: the graphing method, the number line and sign check, the completing square method or completing square form. These two you have already studied. You know how to draw the graph of this, but in this case, while solving quadratic inequality, we will simply draw the graph which will open upward or downward depending upon the sign of A, and we will only mark 2 points. This will be totally rough sketch, and then we will find the solution of the inequality. Steps in solving quadratic inequalities by the graphing or number line method. Step number 1 is write the inequality in standard form. That is, all the terms should be on left hand side, and on the right hand side there must be 0. Solve the quadratic expression on left hand side. After writing the inequality in standard form, we will solve the quadratic expression on left hand side by factorization method if the expression can be factorized. If factorization is not possible, then we will find the values of x by using quadratic formula. In step 3, solve the given quadratic inequality based on the two values of x. After finding these two values in step 2, we will solve the inequality. You may use any one of the following methods: by graphing method or number line and sign check method. We will discuss these two methods in the next few slides. and express the solution set of the quadratic inequality in terms of intervals or range of values of x. So these are the 4 steps which are involved in solving quadratic inequalities by graphing or number line and sign check method. Solving quadratic inequality by completing the square method we will discuss later. Shape of the graph of quadratic function. You are familiar with this. The shape of the graph. If you are given the quadratic function y is equal to ax square plus bx plus c, and if a is greater than 0, then the shape of the graph is a parabola and it always opens upward. The graph may cut x-axis at 2 points like this. The graph may cut x-axis at only 1 point, or graph may not cut x-axis. This is the case when there is no real solution. When you solve the quadratic equation by using quadratic formula, and if under the square root sign there is a negative number, so we say that there is no real node. In that case, parabola will not cut x-axis. So these are the 3 shapes of the parabola. If a is positive, graph may cut at 2 points, it may cut at only 1 point, or it may not cut at any point. This will be the case when there will be no real solution. And if a is negative, then graph will have these 3 shapes, but in this case the parabola will open down, you know it, and it will cut the x-axis at 2 points or at only 1 point, or it will not cut x-axis at any point. So these may be the cases. When you will solve the quadratic expression, you may get 2 values of x, you may get only 1 value of x, or you may not get any value of x in both the cases. Now let's solve the questions by all the 3 methods, by graphing method, by number line method, and by completing the square method. This is the question: x square minus 6x plus 5 less than 0 by graphing method. We will solve this. We will factorize the expression on the right hand side. The inequality is already written in standard form. We will solve this expression. If this can be factorized, we will factorize, because its factor can be formed x square minus 5x minus x plus 5, factorize, and we get these 2 factors. So these are the zeros of this expression or this function, mean these are the points where graph cuts x-axis. These are 2 points at x is equal to 1 and at x is equal to 5. The graph cuts x-axis. These are the 2 points in this case. Because the coefficient of x square is positive, therefore graph will be a parabola which will open upward. You just have to draw a parabola and mark 2 points. One is smaller and another one is larger. In this case, 2 points are x is equal to 1 and x is equal to 5. Mark these points. X is equal to 1 and x is equal to 5. Now look at the sign of inequality. In this case, it is less than 0. That is, though you need to find those values of x for which the parabola, for which the function is negative, Look at this. From this point to this point, function is negative, and from this point to negative infinity, function is positive, and from this point to positive infinity, function is positive. We need those values of x where function is negative, and function is negative this below x-axis, and there is a less than sign only. There is no less than or equal to. So it means from this point to this point, function is negative. So what will be our solution? This value, all the values from 1 to 5 because there is only less than sign. So 1 is not included and 5 is not included. All the values between 1 and 5 are the solution of this inequality where graph is less than 0, negative. If there is greater than sign, then at these values, when x is less than 1, y is positive, and when x is greater than 5, y is positive. So in this case, when x is less than 0, these are the value. So the solution of the given inequality is x greater than 1. You will not write equal to because the sign of inequality in the question is less than only. So this point 1 is not included in the solution of the inequality. Similarly, 5 is not included in the solution of the inequality. Therefore we will write these signs: x is greater than 1 and less than 5. In case of interval, we will write it 1 5, and we will write this close bracket parenthesis. This is called open interval. In the case of interval, when points are not included, we put parenthesis, round bracket, and this interval is called open interval. If these points are included, if there is less than or equal to sign, then we will put a square bracket here, that will be called closed interval, but in this case it is there. So this is the solution of quadratic inequality by graphing. You will find the points where y is 0, the function is 0. So these are the 2 points where function is 0. Mark these 2 points and check for what values of x the function is negative or positive, looking at the sign of the inequality in the question, and then write that range. Now by solving this question by number line or and sign check, the method is same. You will do the whole working from this step to this step. These are the points where graph is 0, y is 0. You will draw a number line, and mark 2 points. Because there is less than sign only, you will draw 2 circles which are not shaded. This point is 1 and this point is 5. Now sign check. There are 3 intervals, from 1 to negative infinity, from 1 to 5, and from 5 to positive infinity. Take any point in this interval. What are the points below less than 1? Less than 1 there is 0. So put 0 in these factors. 0 minus 1 is minus 1 and 0 minus 5 is minus 5. When you will multiply minus 1 with minus 5, you will get plus sign. So in this interval we are taking test points. In this interval the test point is 0. In this interval you can take test point 2 or 3 or 4 or 5, 4, and in this interval you can take 6, 7, 8, 9, 10, whatever. So I am taking 0 as a test point in this interval. Putting 0 in this, we get positive sign, and putting 2 which is in this interval, in these factors, 2 minus 1 is plus 1 and 2 minus 5 is minus 3. Plus 1 multiplied by minus 3 will give you a negative sign. So in this interval the sign of the function is negative. Now in this interval, when you will put 6 here, 6 minus 1 is 5 and 6 minus 5 is 1. Plus 5 multiplied by plus 1 will give you a positive sign. We need those values of x where function is negative, less than, and function is negative from 1 to 5. 1 is not included and 5 is not included. So all the values of x between 1 and 5. So solution of the inequality is x greater than 1 and less than 5. So graphing and number line method almost same. You just have to draw a graph after this point, or you have to draw a number line and you have to check the sign of the function between the intervals like this. Have a look at this. So this is the question which we have solved by graphing and number line method. Now we will solve the same question by completed square form. Now solve another question by graphing and number line method. 2xk plus 3x minus 3 is greater than or equal to 0. Now because this expression cannot be factorized, so we will find the 2 points where graph crosses x-axis. We will do this by the completed square form. We will find two values of x where graph crosses x-axis. These are the two values. X is approximately equal to 0.69 or minus 2.19. Now we will draw the graph. Because the coefficient of x square is positive, graph will be a parabola which will open upward. And these are the 2 points where graph cuts x-axis. Mark these points. Now check the values of x where graph is positive. Look at this sign. This sign is greater than mean positive. So all the values where graph is above x-axis, and those values are which are greater than 0.6, graph is above x-axis, and which are less than minus 2.9, graph is above x-axis. When x is greater than minus 2.1, graph is negative, and when x is less than 0.69, graph is also negative, below x axis. So we need these values, this point and all these values, and this point and all these values. So solution of inequality is x less than or equal to minus 2.19 and x greater than or equal to 0.69. So solving same question by using number line and sign check method. Draw the number line, mark 2 points. Now check the signs, check point. Take any point in this region and put that value in this equation to get the check the sign of the answer. In this region there is a number negative minus 3. When you will put minus 3 in this equation, you will get the sign of the answer which is positive. Take any point in this region which is 0, put 0 here and you will get a negative sign, and any other point in this region which is 1, put 1 here and you will get a positive sign. So you need these values. The graph is positive from this point to this point, positive infinity, and from this point minus 2.19 to negative infinity, and between these 2 point graph is negative. We do not need these values, so we will write as we did in the graphing method. Now we will solve the same question by using completed square form. We will complete the square and write the expression in this form. Now we will solve this and we will get this simplest form. Now we will take the square root of both the sides. As in the last question I have told you, when you take the square root with the negative square root of this number, you will change this sign, and with the positive square root of this number you will keep this sign like this. X plus 3 is less than or equal to, there is greater than or equal to, change this sign to less than or equal to and take the negative square root of this. Negative square root of this is minus square root of 3 over 4, and with the positive square root keep the same sign, this. Now simplify these two to get the answer. x less than or equal to this or x greater than or equal to this. When you will simplify this, you will get minus 2.19, and when you will simplify this, you will get 0.69, and you get the ultimate answer, which is same as you find the answer in graphing or number line method. So these are the three methods. You can choose any one of your choice to solve the quadratic inequality. You can solve this inequality by graphing method, by number line, or by this completed square method. It's up to you. Now let us solve another question by graphing and number line method. In this question, the coefficient of x square is minus, so the shape of the graph will be a parabola which will open down. Factorize this if possible. Yes, the factors of this expression are possible. So factorize this and find two values where graph crosses x-axis. The graph crosses x-axis at x is equal to -4 and x is equal to 2. Now we will draw the graph. The shape of the graph will be a parabola, and it will open down like this. Mark 2 points on this graph where it cuts x-axis, and label these 2 points. Now we will check the sign of the graph. Here in the inequality there is a less than or equal to sign, so it means you need those values of x for which the graph is negative, below x-axis. Look at this. This is the parabola which is above x-axis, and these are positive values of y, and this part of the parabola and this part of the parabola is below x-axis, so all the values of y are negative. Now these values of y or function which are negative exist when x is equal to 0 or greater than x is equal to 2 and greater than 2, or x less than or equal to 4. These values and these values. At x is equal to 2 it is 0, and when x is greater than 2 the value of y is negative, below x-axis. When x is equal to 4, -4 it is 0, and when x is equal to x is less than -4 the graph is below y-axis, below x-axis. So the range of values of x are from x is equal to 2 to positive infinity, and x is equal to -4 to negative infinity. The solution of the inequality is all the values of x which are less than or equal to -4, because equality sign is included in the inequality, and x is greater than or equal to 2. Similarly, you can solve this question by using number line. All the method steps are same up till this point. Up till this point you will solve the questions in the same way. Instead of drawing the parabola, you will draw a number line. Draw the number line after this step and mark 2 points on this number line. Mark the point, one is -4, other is 2. Now you will check the sign in this region, in this region, and in this region. From -4 to negative infinity you can choose any point and put that point in these factors to check the sign of this expression. Here there is -5 in this side, so -5 plus 4 is -1, and 2 plus 5 is 7. -1 multiplied by plus, you will get negative sign. In this region 0 is included in this region. From -4 to 2, put 0 here. 0 plus 4 is +4, and 2 minus 0 is +2. So +4 multiplied by +2 will give you +8, which is positive. From 2 to positive infinity you can take 3 here. 3 plus 4 is 7 and 2 minus 3 is minus 1. 7 multiplied by minus 1 is minus 1. So in this region, from minus 4 to negative infinity, sign of the function is negative. From minus 4 to 2, sign is positive, and from plus 2 to plus infinity, sign is negative. So we need these values of x which are equal to minus 4 and less than minus 4, and which are equal to 2 and greater than 2. So this is again the solution of the number line. You cannot write these two as double inequality because there is a gap between these two range values of x. So instead of drawing graph in this number line method, you will draw this number line. You will replace this number line by this parabola, or if you want to solve or find the answer by graphing method, so you have to draw the graph. Now we will solve this equation by completed square method. Solve this equation by completed square method. Write this expression in completed square form first. The method, you know how to write this expression in completed square. This is the completed square form of this expression. Now we will further solve this to find the values of x. We will transfer plus 9 to right hand side, which will become minus 9. Now here, because this is inequality, to make this positive, we will multiply both sides of the inequality by negative sign, and you know that when we multiply both sides of the inequality by a negative sign, the sign of inequality changes. So we will change this sign of inequality here. So it will become x plus 1 whole square greater than or equal to plus 9. Now we will take the square root, and as we have solved some questions in the previous slides, that when we will take the negative square root of this, we will change this inequality sign. So x plus 1 less than or equal to minus 3, or x plus 1 is greater than or equal to plus 3. With plus positive square root, we will keep the same sign which is in the question here in this step before taking the square root, and we will change the sign of the inequality with the negative square root. Now we will solve these two inequalities, which becomes linear inequality. So x is less than or equal to minus 4, or x is greater than or equal to 2. So this is the solution of this inequality, which we have solved by completing the square method. So there are three methods which we just have studied. Quadratic inequality can be solved by graphing method, by number line and sign check method, and completed square method. You can use any one of these three. It is better to use completed square method when the factorization is not possible, or in every case you can use the completed square method, but it is up to you. Now try these two questions, solve these inequalities. The answers will be given in the next lesson. Exam techniques. 1 mark question will often use phrases such as write down or state the value of. Questions like these generally require no working. So if you find yourself attempting a long calculation, the chances are that you are missing the point of the question. So when the question has 1 mark and question is asked by these phrases, so it means the question does not require any working, long working. You can do 1 or 2 steps for your convenience, but a long working mean you are not understanding the question. This is my profile. Thank you for watching this video. Allah Hafiz.